Here we go. So we are live. So today we're going to talk about rational exponents and roots. Before we do anything, let's do two real quick reviews. Okay. One, we're looking for perfect square numbers, right? And these are all the numbers that have square roots. So we're doing our multiples. We want to find one of these, right? Or read that because all of these numbers have square roots. So we want to look for our perfect squares, right? So we want to look for our perfect squares. Perfect squares. And the second thing we want to look at is exponents with x's, okay? So, before we do anything, I just want you to write this down, please. So, x cubed times x cubed. Okay, just write that down. X cubed times x cubed is x to the sixth, right? Because you add the exponents. Now, if I wanted to take the square root of x to the sixth, it has to be x cubed, right? Because the square root is like what times what equals that thing, right? It has to be x cubed. So the square root of x to the sixth is just x cubed. So what did I do? I mean, give me a real quick little rule. What did I do?
Divide exponent by 2.
Right, I took half. That we're saying the same thing. So I took half the exponent. Took half the exponent. So it had to be an even number to take half the exponent. So let's go ahead and highlight that. So I took half the exponent, okay? So if I did, as another example, if I did the square root of x to the 10th, the answer is what? Come on, you guys. Square root of x to the 5th, right? So we just take half the exponent. Okay, everybody all right with that? Thumbs up. Does that make sense? And the reason would be because we know x to the 5th times x to the 5th, x to the 5th times x to the 5th has to be x to the 5th. Okay, and I'm going to write that up there. We know. Okay, y. I'm going to put a big Y because x to the 5th times x to the 5th is x to the 10th. Okay, so in case what we did is we just learned if it's an exponent, we just take half of it. Okay. Now, if it's not an even number, we're going to figure out what to do with that also. Okay, so I want to show you here in this very bottom box, if it's not an even exponent. Okay, so if I had the square root of x to the 11th, we're not going to put 5.5. We're not going to put 5.5. What we want to do is we need an even number. We need an even number, okay? So we need an even number or an even exponent. Okay, so what I'm going to do is rewrite this as the square root of x to the 10th times the square root of x to the 1. So if I take 1 away from it, it makes it even, right? Does that make sense? And I want to take as much out as I can, so I'm only going to take 1 away. I'm only take 1 away from an odd, and it makes it 10 and 1. Everybody okay with how I did that? Right? Square root of x to the 11th is x to the 10th and x to 1, right? And now we can do it. We can do x to the 10th. We just did that up above, right? Square root of x to the 10th was x to the 5th, right? Every grade, we took half of that. So if it's an even number, you can take half of it. So then we'll get x to the 5th. But now we can't do that one. So it just stays square root of x. Because you're not going to take half of 1, okay? How's that? And we're going to see that in today's notes. So we know two things. If it's a number, if it's a regular number, we're going to be looking for perfect squares, right? If it's a regular number. And when we get to the exponents, we're going to take half of the exponent. But it's got to be an even exponent, okay? Thumbs up? Okay, let's start with the first one, which should be pretty easy. Have you guys already got an answer for the first one? Savannah's, yeah, I got it. Savannah, what'd you get for an answer? 2 square roots of 5. Thumbs up? Okay, and I'll show it real quickly, just in case. Savannah went square root of 4, square root of 5, right, Savannah?
Yeah.
Square root of 4 is 2, and there you go. Bam, right? Easy? Okay. How about number 2? Anybody got an answer? Give it a try. What'd you get? 3 times square root of 25, square root of 3. I like that. That's a great idea. 25 and 3. 25 is one of our perfect roots. Everybody agree? 25 and 3. Okay, and then keep going. Then what? 3 times 5 square root of 3, right? 15 square root of 3. Okay. How many kids got that answer? Raise your hand. I want to see. Did you get that answer? Did you get that answer? Okay, good. All right. Now, example 3. Let's do example 3 together. First of all, okay, we're doing square roots, right? Square roots. That is a regular 2. It's a regular 2. So let's write it down. Just write it down, leave it alone. Just write it down. Okay, just write it down, leave it alone. Okay. But what about the 8? What do you do about the 8? What about the 8? Alex, what times what makes 8? Awesome. Square root of 4, square root of 2, because we haven't taken the square root of it yet. And then we can take half of that, can't we? And I'm going to make that just a plain old x, okay? So I took half of that. I could put an x to the 1. I can put a 1 there because half of 2 is 1. I don't need, you guys agree I don't need the 1, but we'll put it there anyway just to be redundant. Okay, let's see what we have. Got a regular 2 times another regular 2, and then I'm going to pull the x because I like everything out in front. I like everything out in front that has a root, okay? And then the square root of 2 is stuck inside. Okay, guys see what happened? This regular 2 is here. Square root of 4 is 2. We took half of the x squared and got the x. I like everything in the front that's out, and then with the square root of 2. And then finally get an answer of 4x squared to 2. Thumbs up? Thumbs up? Sideways? All right, let's try the next one. Okay, so I would tackle this one by multiplying first. Regular numbers with regular numbers, okay? Whole numbers with whole numbers, square root numbers, square root numbers. So let's just get a 12 square roots of 18, okay? Okay, what do you see? What do you see? What do you see? Do you see anything? I do.
9,
What do you see?
92.
You guys agree with 9 and 2? I like that. Okay, so we got this 12, square root of 9, square root of 2, right? We all know the square root of 9 is 3, square root of 12, times 3 square root of 2. Am I going too fast? Am I okay? If you're going too fast, let me know. 12 times 3 is 36 square root of 2. Okay. Pretty easy so far. No problem. Okay. Example 6, sorry. Example 6. Oh, I missed a 4. 4 is there. Oh well, don't ask me. 6 is going to be a little bit more work. Okay, so you ready? Are you watching? Do you see a 6x? Do you see 6x? Say, I'm going to have a 6x, regular old 6x, times the square root of 36x to the 4th, okay? So I multiplied the outside terms, multiplied the outside, and then I multiplied the inside or the square terms. Okay, now what do you see? Hopefully you see something really easy, okay? Don't break down the square root of 36. You know what the square root of 36 is. It's just plain old 6. Everybody agree? I mean, you could make it 4 and 9, but that would be like extra work, right? Square root of 36 goes straight to a 6, right? And what about the x to the 4th? Take half of it, half the exponent. So we get x to the 2, right? And there's nothing left inside. Everything's been taken out of the square root, so you're just going to slide this slide this 6x down in front. And they're together, right? If they're together, we're going to multiply them. So I'm going to get a 36x cubed. Okay, a little bit harder. Not too bad. Okay. All right, example 4, which is out of order, but that's okay. I think I rewrote it this way because example 4 is harder than example 6. That's why I put it there, okay? Okay, so what do you think? First thing I see is this 5x. I'm just going to leave that alone, right? Bring it down, leave it alone. So let's put the 5x down. And then what about the 27? What times what makes 27?
3 and 9.
Okay, how about 9 and 3? We're saying the same thing, aren't we? Yep. Square root of 9, square root of 3. But what about x to the 5th? So it's odd, right? It's odd. What do we do over here? We took 1 away from it, right? We took 1 away from it, okay? We're going to do the same thing here. We're going to make this the square root of x to the 4th, square root. So we're going to make it a square root of x to the 4th times the square root of x, okay? So I took 1 away from it. And then that made it even, okay? Because you need an even exponent, so you can take half of it, okay? All right, let's see what we got. Okay, so I've got a 5x. I've got the square root of 9 is a 3. I'm going to take half of this, which makes it x to the second. And what I'm left with is the square root of 3 and the square root of x. Those two things cannot be simplified. So I'm going to leave them inside the square root. Together, right? Together. Put them together. Okay, now let's finish this up. 5 times 3 is 15. X to the third, right? X to the third, square root of 3x. Okay, how's that? All right. Thumbs up. Okay, hopefully you learned this in algebra. Maybe. Did you? Maybe. Maybe not. I don't know. All right, ready to turn the page? Okay, we can do this one. In fact, this might be the same one we had even on the warm-up, right? So you cannot add them. At least not right now. Can't add them. Not right now, Nate, but maybe, Nate, if we mess them up and rewrite them and find multiples, maybe we can add them. What do you think? So what are we going to do? 2 times, what are we going to do with the 8? Emma, what are we going to do with the 8? Oh, Palmer? Good. Let's pick on the Emmas. 4. Okay. Emma, what do you think? Square root of 18? 9 and 2. Okay. Emma Nielsen, we're picking on all the Emmas right now. Emma, what are you going to do next? Okay, good. I like skipping steps. Thank you very much, because we know that's a 2 times that 2 is 4. Everybody agree with that? Plus. Keep going, Emma. You're doing great. See, she made that a 3 times 4 is 12. Square root is 2. Everybody okay with that, skipping that step? You know what she did? She made that a 3 times 4. Okay, and grand total Emma's, what's the answer? 16 square root is 2. My name's not Emma. All right, example 9. Let's see. Example 9. Sure, go ahead, Megan. Yeah. All right. What's that say? Cannot have a square root in the bottom of a fraction, right? Cannot. So how do we do it? We fix the problem with the problem, right? So let's take a look at this one. It's breaking the rule, but how do we fix it? Okay, we're going to multiply both top and bottom by the square root of 3 over the square root of 3. And how's that going to fix it? We really will fix it. We're going to wind up with, well, that's not a square root. So we're going to get a 5 square root of 3. 5 square root of 3. You can't multiply those because that's not a square root. Over the square root of 9. Can I skip a step? No, I'll put it down. Square root of 9, right? I'll show every little step, right, Ben? Helps everybody, okay? And then I get 5 square root of 3 over 3, okay? All right, everybody listen. Please listen. Everybody. Do not cancel these. That is not a 3. That is not a 3. You're like, come on, Mr. Davies, are you blind? That's a 3. That's not. That's 1.73. That's 1.73, blah, blah, blah. That is not a 3. That's 1.73, I don't know. Hold on. I don't know the rest of it, but I do know it's 1.73 something or other. Square root 3. I've got to turn it on. That always helps, doesn't it? Square root of 3. 1.73205. So that is not a 3. So if you cancel these, you're calling this a 3. That's not. That's your answer. Don't cancel those. That is 3, by the way. Okay. Everybody agree with that? Don't cancel those, okay? All right. Last example. All right, what do you think? Any ideas? What do you think?
27 is 9 times 3.
I like that idea. 9 times 3 over 2 square root of 6. Great. Now, you can't break up 6. Everybody agree with that? But you could, and it might help you out. There's 2 ways to do this problem. There's 2 ways. Okay? You want me to show you the easy way? What if you made this square root of 2 times square root of 3? How would that help you? Square root of 2 times square root of 3. How would that help you? Square root of 2, square root of 3. How would that help you? Square root of, well, I'll write it down. If you can't see it, you're going to go, okay, wait a minute, Mr. Davies, I think I can do this. 3 square root of 9 square root of 3 over 2 times the square root of 2 square root of 3. Hey, what do you think now?
The 3's cancel out.
Right.
And the 2 square root of
You guys okay with that? Well, that we're stuck with. But we have at least a 3 times a 3. You guys with that? Over 2 squared root of 2. You okay with that?
No.
Okay, I'll back you up, okay? All right, back you up. Square root of 6 is 2 times 3, okay? And the reason I wanted to do that is because I saw I could cancel those. Is there another way? I'm going to show you the other way too, okay? I'm going to show you both ways. Let me show you both, okay? And now from here, I'd have a 9 over 2 squared root of 2. Okay, now we have a problem, don't we? We have a problem. What's our problem? What's the problem? Right, and you can't have the square root of 2 on the bottom, so we fix the problem with the problem, right? Square root of 2, square root of 2. And I'll wind up with an answer of 9 square root of 2 over 4. Is that going to bother you if I put a 4 down here? Where'd the 4 come from? Okay, I want you to think. That's the square root of 4, which is 2, times that 2 is 4. Okay, now you want to see the other way, right? So let's do the other way, and I'll do it on the whiteboard, okay? So you can see both ways. So let's say you didn't do that way, okay? Let's go back to the original problem, okay? So you can see the original problem. Because there's 2 ways to do this, okay? Go back to the original problem is we can go the square root of 9, square root of 3 over 2 square root of 6, right? So far so good, right? And then we can go 3 times 3 square root of 3 over 2 times square root of 6. How are we doing, okay? So far so good. And then what you can do is, same thing, fix problem with problem. We'll apply this by square root of 6 over the square root of 6, right? Which is going to give you, am I going too fast? It's the other way to do it, which is going to give you 9 square roots of 18 over 2 times 6, which is 12, okay? But, can you do anything with the 18? Sure. So you do the same thing with the 18. 9 times square root of 9, square root of 2 over 12. How am I doing? Which is 9 times 3 is 27 square roots of 2 over 12. Now at this point you look at it and go, wait a minute, those aren't the same answers, are they? They're not the same answers, but what could you do with the 27 twelfths? You could reduce that, right? Reduce them both by 3. If you reduce that by 3, like any old fraction, you get 9 fourths, you get the square root of 2, okay? Both ways work. Just either way, it's a fun problem.